Hello everyone. Today we are going to discuss 10th Standard Chemistry, Chapter Chemical Reactions and Equations. The topic is Types of Chemical Reactions. We can easily follow the 5 different types of chemical reactions with the help of some balls. First is combination reaction, second decomposition reaction, third displacement, and fourth is double displacement reaction, and the last is oxidation and reduction. So we are moving to the first concept, combination reaction. In a combination reaction, two or more substance or elements or compounds are combined to form only a single product. So the key point is a single product. That is, generally we can say A combined with B gives AB. Here the participants A and B are either elements or compounds. Let's have an example for each. We know hydrogen react with oxygen to form water. Here the two reactants are two elements, that is hydrogen and oxygen, and we get a single product, that is H2O, and it is an example for combination reaction. Another example for combination reaction in which we get a single product is carbon plus oxygen gives carbon dioxide. One more example is magnesium plus oxygen gives magnesium oxide. Now we are going to examine combination reactions in which the reactants are compounds which are formed by combining two or more elements. Calcium oxide, which is known as quicklime, react with water gives calcium hydroxide, which is known as liquid lime. Here in this example, the two participants or reactants are compounds, that is calcium oxide and water. In this reaction, lots of heat energy is released, and this type of reactions are known as exothermic chemical reactions. One of the most familiar exothermic reaction is respiration process. We can feel this slight heat by applying our palm in front of our mouth. The decomposition of vegetable matters is also one example for exothermic reaction. Next, we have an interesting question. Do you know what is happening in whitewashing? In last example, we have noticed one product, that is calcium hydroxide, which is known as slaked lime. A solution of this calcium hydroxide or slaked lime is used for whitewashing process. We know carbon dioxide is plenty in our air. So after whitewashing, the calcium hydroxide react or combine with the carbon dioxide and forms a thin layer of calcium carbonate. This is a slow process which takes 2 or 3 days and gives a shiny finish to the walls. Next we are going to the second classification, which is decomposition reaction. From the name itself, it is clear that the decomposition of a substance is taking place here. That is, a single reactant or substance break down into smaller products. In general, we can say the reactant A, B breaks down into smaller products A and B. Here, in order to decompose a reactant, it needs some sort of energy, either in the form of heat or light or electricity. And this indicates endothermic reaction. That is, reactions in which energy is absorbed, either in the form of heat or light or electricity, are known as endothermic reactions. We already studied in 7th standard. One of the most common example for decomposition reaction or endothermic reaction which requires electricity as energy is electrolysis. In electrolysis, the single reactant, which is water, absorb electricity and decompose. Here, the resulting simpler or decomposed products are hydrogen and oxygen gases. The corresponding chemical equation can be written as 2H2O gives 2H2 plus O2. Let us analyze some more examples for decomposition reactions in which heat and sunlight are absorbed as energy. In first example, we are taking some crystals of ferrous sulfate and it exposed to heat. So when heat is applied, the crystal loses water and changes its color. It then decomposes into three simpler substances. The solid we can see is ferric oxide. The other two products are sulfur dioxide and sulfur trioxide gases, which are a little bit toxic in nature. That is, 2FeSO4 gives Fe2O3 plus SO2 plus SO3. Another example is decomposition of calcium carbonate to form calcium oxide and carbon dioxide on heating. We already discussed that calcium oxide is quicklime and it has many industrial use like in manufacturing of cement likewise. Here the chemical equation can be written as CaCO3 gives CaO plus CO2. In these two examples, heat is used as energy for decomposition. This kind of reactions in which heat energy is used for decomposition is known as thermal decomposition reaction. Next we are going to decomposition reaction in which sunlight is used as energy. Here, when silver chloride exposes to sunlight, its color changes into grey, and this is due to the decomposition of silver chloride into silver and chlorine. And same thing happens to silver bromide also. That is, when silver bromide exposed to sunlight, it decomposes into silver and bromine. This decomposition process is used in black and white photography. Here, film or photographic plate contain this silver bromide. So, when it is exposed to sunlight, this silver bromide decomposes and we get a black and white image. When we compare decomposition reaction and combination reaction, we can understand that they are exactly opposite. That is, in combination reaction there is only one product, but in decomposition reaction there is only one reactant. Next we are going to the third type of reaction, that is displacement reaction. We know the reactants in a chemical reactions are either elements or compounds which are formed of one or more elements. In displacement reaction, the less active element in a compound in the reactant side is replaced by more active element in the reactant side itself. That is, more active element displaces or takes the place of less active element in a compound. In general, we can write like this. Here in the reactant side, C is the less active element in the compound BC, which is replaced by more active element A, and we get a new product AB. Here, which element is replaced or which element replaces the other depends upon the reactivity series in chemistry. Here, this picture shows the reactivity series of metals. In this, the reactivity decreases when it goes down. Now we are moving to an example for displacement reaction. Here we are making copper sulfate solution and we are going to dip some iron nails in the solution. Here iron is more reactive than copper in the copper sulfate solution. So as a result, iron replaces copper in the copper sulfate solution and becomes iron sulfate plus copper. After some times we can see the color of iron nails are changed into copper color. Also the color of copper sulfate solution is changed from bluish to light green color. Here the corresponding chemical equation can be written as Fe plus CuSO4 gives FeSO4 plus Cu. We can have another example. A zinc plate is dipped in copper sulfate solution. Here zinc is more reactive than copper. So zinc replaces copper sulfate into zinc sulfate solution and copper we get another product. Here also we can see the difference after some time. In this reaction the color of zinc plate is completely changed and also the bluish color of copper sulfate solution completely disappear. The equation is Zn plus CuSO4 gives ZnSO4 plus Cu. This is also known as a single displacement reaction because a single element or ion is replaced here. Now I am going to ask you a question. When a copper piece is dipped in an iron sulfate solution, what will be the result? Is the result is CuSO4 plus Fe?
The answer is no.
Because iron is more reactive than copper.
So copper cannot replace iron in iron sulfate solution. That is, they will not take any reaction here.
One more important thing is that the reactive series will be used only for single displacement reactions.
Now we are moving to the fourth type of reaction, that is double displacement reaction.
We know when we take a compound, for example silver chloride, that is AgCl, there is a positive ion and negative ion.
We call it as cations and anions respectively. In double displacement reaction, there will be two compounds as reactants and they exchange their ions, either cations or anions, to form new substance. That is, in this type of reaction, more than two compounds or reactants react with each other and exchange ions to form new compounds. In general, we can draw like this. Compound AB react with CD and exchange their anions B and D with each other and we get new compounds like AD and CB.
So as we mentioned earlier, the double displacement reaction is not based on reactivity series, but it is exchange of anions or cations.
Here is two examples for double displacement reaction. First is silver nitrate react with sodium chloride. Here the anions, that is negative ions NO3 and Cl, are exchanged with each other and we get the result AgCl plus NaNO3. And the second is barium chloride react with sodium sulfate and we get barium sulfate and sodium chloride.
Here in these reactions we can see some sort of water insoluble matters are formed. We call it as precipitate, and such reactions which produce precipitates are known as precipitation reaction.
The last type of classification is oxidation and reduction. We call it as redox reaction. It is very easy.
In a chemical reaction, if a reactant gets oxygen, it is said to be oxidized. Similarly, in a reaction, if a reactant loses oxygen, it is said to be reduced. Or we can say when a reactant loses hydrogen, the reactant gets oxidized, and when a reactant gains hydrogen, the reactant gets reduced. That is, the case of gaining oxygen and losing hydrogen is known as oxidation, and the case of losing oxygen and gaining hydrogen is known as reduction.
Here is one example. CuO plus H2 gives Cu plus H2O.
Here in this case, copper loses oxygen and it is said to be reduced, and hydrogen gains oxygen and it is said to be oxidized.
The reactant which helps oxidation process is known as oxidizing agent, and the reactant which helps the reduction process is known as reducing agent.
Here the substance CuO helps hydrogen to get oxidized. So CuO is the oxidizing agent. Similarly, hydrogen helps CuO to get reduced. So hydrogen is the reducing agent. Next, if in a chemical reaction both oxidation and reduction happens in one time, then it is said redox reaction. There are so many examples for oxidation reaction in our day-to-day life.
One of the most common example is rusting of iron, which we have mentioned in the earlier classes.
Like iron, the two commonly used metals are copper and silver.
When these metals are attacked by substances like moisture, acids, etc., it is said to be corrode, and this process is known as corrosion.
Another effect of oxidation process is rancidity. The term rancid means the degradation of oil content foods when it is contact with oxygen in the air, or we can say as an effect of oxidation process. So in turn we can see the food color, smell and taste will change. We know food items like meat, fish or packed items, when it is contact with air, then it will combine with oxygen and as a result the food becomes useless. So in order to avoid this rancidity, we can keep this food in a refrigerator, or food manufacturers remove this oxidant content and insert some kind of antioxidants while packaging. We can also see airtight packets of chips in which oxygen is removed, and instead of this they are filling nitrogen gas in order to avoid this rancidity. So we are winding up today's class. If you have any doubt then please mention it on the comment box, and thank you for watching this video.